Hello everyone, welcome to the channel Topgate. In this video, we'll see Greeback normal form or GNF. So in the last video, we have seen what is Chomsky normal form, and I told you that the Chomsky normal form is the lower form of the context-free grammar, whereas this Greeback normal form is the highest form of the context-free grammar. So in the first part of the video, we'll see some basic points about the Greeback normal form, and in the second part of the video, we'll take up an example where I'll tell you how to convert a context-free grammar into a Greeback normal form. Okay, so the first point says that a CFG is in GNF if every production is of the form A tends to A alpha, where alpha belongs to Vn star and A belongs to sigma. This says that in every production rule, left hand side should be a single variable, that is the definition of the context-free grammar, and the right hand side should start with a single terminal followed by any number of variables. Since we have this alpha belongs to Vn star, that means this alpha is the combination of any number of variables including null. So we can have even a null here, or we can have any combination of any number of variables. Clear? So the type of production rules that we allow in a GNF are, the first one is we have this A tends to small a when we keep this alpha as null, because this alpha is Vn star also, and star contains null also. So if we keep this alpha as null, then we can have this type of production, and if we keep that alpha as non-null, then I can have anything here. That means I'll start with a single small terminal followed by any number of capital letters. So only these type of production rules are allowed in this Greeback normal form. Clear? Okay, next point says that this Greeback normal form is helpful for top-down parsing algorithms, like we have this recursive descent algorithms. So it is actually very helpful in all of these kind of algorithms where we are doing top-down parsing. Okay. Now the next point says that it is also helpful in constructing a PDA. Now the machine which implements this context-free grammar is a PDA, that is a push-down automata, and for a push-down automata, this Greeback normal form is actually very helpful. Okay. Now the last point is the prerequisites of this Greeback normal form are, we first have to ensure that all of these points are satisfied before converting a context-free grammar into a GNF. It says the first step is to remove the useless symbols first, then we have to remove the null productions, then we have to remove the unit productions, then we have to eliminate the left recursion from the context-free grammar, and then we have to convert it into a CNF form. Out of these 5 steps, the last one is not mandatory, it is an optional one. If you convert the context-free grammar to CNF first, then it would be easier for you to convert into GNF. Clear? And for all these steps, I have already made the videos. So if you haven't watched those videos yet, just go to those videos, watch it once. How do we remove the useless symbols? How do we remove the null productions, unit productions, left recursion? How do we convert to CNF, so that it would be easier for you to convert a context-free grammar into a GNF. Okay, now let's take an example where I'll tell you how to convert a context-free grammar into a GNF. So let's take this example. Here we have this context-free grammar, and this context-free grammar has to be converted into a Greeback normal form. So first of all, let's see what are the production rules allowed in a Greeback normal form. We have A tends to small a, and we have A tends to small a followed by any number of variables. So these type of production rules are allowed in a Greeback normal form. Now, if you observe this one, in this one you can see that we don't have any null productions, we don't have any unit productions, as well as if you can see we have this S deriving a small letter, that means derivability is there. A deriving a small letter, again derivability is there. And if you can see that this A is reachable from the start symbol, that means the derivability and the reachability property is satisfied in this particular context-free grammar. So in this one, we don't have any useless symbol, we don't have any null production, we don't have any unit production, so I can directly convert this grammar into a GNF. Now let's see. In this one, we have 1, 2, 3, 4 production rules, and out of these 4 production rules, this one and this one, these are already in a Greeback normal form, whereas this one and this one is not in GNF. So I'll do something to convert this one and this one into a GNF form. Now let's see how we do this one. If you can observe in this one, in S we have this A variable, and in this A we have this S variable. So I have two options. Either I can put both of these values here onto this A, or I can put both of these values here onto this S. Okay. Now, how will it help us? Let's see how we do this one. So what I'll do, I'll just substitute A into S. Clear? So that means I'll put these values here onto this A. So let's see what happens to my grammar. We have S tends to, on this A, I'll put this value first. That means SB followed by this small a slash, then this value, that means A followed by this one, A slash, and then I'll write this B as it is. Clear? And then for A, what we had, we have A tends to SB slash A. Clear? Now, if you can observe this one, in this particular rule, we have this S tends to SBA. That means here we have a left recursion. That means the variable on the left hand side is also appearing onto the right hand side, but on the extreme left position. So this is called as a left recursion, and we have to eliminate this left recursion before converting this grammar into a GNF form. Okay, now let's see how we just eliminate this left recursion. So first of all, let's see what is the formula for eliminating the left recursion. That means if we have A tends to A alpha slash beta, then how do we write it? We write it as A tends to beta A dash, and then I define A dash as alpha A dash slash epsilon. So whenever we see this kind of left recursion, we write it in this particular format. Okay, so now I'll take this production rule and then I'll convert it into a non-left recursion format. Let's see what do we have. We have S tends to SBA slash AA slash B. Now this is the same variable here, and this one will become my alpha, this one will become my beta 1, and this one will become my beta 2. Let's see how we eliminate this left recursion. It says that we will take S as beta. What is beta? Beta, we have two betas here. That means I'll take AA, then I'll take a new variable S dash. Similarly, I'll take for beta 2 also. That means B followed by a new variable S dash. And then I'll define S dash as alpha. What is alpha here? BA, and then S dash slash epsilon. Clear? That means this production rule is actually converted into this one. This is with left recursion and this one is without left recursion. So the grammar that I have now is, I have this S tends to AA S dash, B S dash, and S dash as BA S dash slash epsilon, and then we have this A tends to SB slash A. Now if you can see here, we have this epsilon also. Now I'll just eliminate this null value and let's see what happens to my grammar. So now I'll eliminate S tends to null. I'll work on this one. Let's see what happens to my grammar. So now I'll get S tends to AA S dash slash B S dash. That means I'm just writing everything as it is. And now I'll just put the S dash as null. Let's see what happens. If I put a null value here, I'll get only AA. And then if I put a null value here onto this S dash, I'll only get small b. Clear? Then we have S dash as, we have BAS dash, and then this null has been eliminated. And if I keep a null value here, I'll get only BA. Clear? And then we have A tends to SB slash A. Now this is the grammar we have. In this one, there is no left recursion, you can see, there is no null, and there is no unit. Now I'll just convert this grammar into a GNF form. So first let's clear this board and then I'll tell you how to convert this into a GNF form. Now we have got this context free grammar, and in this one, if you can observe, we don't have any null productions, we don't have any unit productions, we don't have any useless symbols, and there is no left recursion as well. So now I can just directly convert it into a GNF. Let's see how we do this one. If you see this grammar, you can see that we have this production rule already in GNF, this one already in GNF, and this one already in GNF. Rest, these few are actually not in GNF. Let's see how we convert this to GNF form. If you see this one, we have this as dash here. We have this as dash here. So that means if I replace this with a single variable, then it will be a GNF compatible. Let's see how we do this one. Let's assume let x tends to a s dash. Okay, so whatever we are assuming, that should also be in the GNF form. So this one is actually in GNF form. And if you can observe this one, we have this a. If I put a variable here onto the second a, then this will also be converted into a GNF form. Okay, so let's assume y tends to small a. So this we have assumed and this we have assumed, and both of these are actually in GNF form. Now I'll put these values here onto this grammar. Let's see what will I get in my final grammar. I'll get s tends to a, and onto this as dash I'll put this x, so I'll get a ax converted into GNF form. Then I'll write b s dash as it is because it is already in GNF form. Then I'll write the first a, and onto the second a I'll put this y, so this is also in GNF, and then I'll write b here already in GNF. Then for s dash, let's see what I'll do. We have this b as dash, so I'll just write b, and this as dash is x now, so I'll just write x here, and then I'll write b, and onto this a I'll write this y. This is also in GNF now. And then we have a tends to s b slash a. Okay, now if you see this one is in GNF, this one is in GNF, this one is in GNF, this one is in GNF. These two are in GNF, but only this one is not in GNF. Now let's see how I convert this one. If you can see, we have a tends to sb. So if I replace this b with some variable, let's say we take z as b. So I'll just write z tends to b. So this again in GNF form. Okay, so if I put this value here, what will I get? I'll just replace this b with z. Clear? Now I have got this a tends to sz and a. Now everything is already in GNF except this one. Now if you see, we have a tends to sz, and for s we have 1, 2, 3, 4 production rules, and all of these 4 production rules are actually in a GNF form. So if I put these values here onto this first s, this will be converted into a GNF form too. So let's see how we substitute these values here. So what I'll do now, I'll just substitute s into a. So what will I get? Let's see. So we have this, first of all, whatever we have assumed, so I'll just write it as it is. X tends to a s dash, then we have y tends to small a, and z tends to small b. Then we have s tends to a x slash b s dash slash a y slash b. Then we have s dash tends to b x slash b y, and then here what I'll do, I'll just put these values here. That means a tends to, onto this s I'll put all of these values here. So what will I get? First of all, ax, so I'll just write ax followed by z. Then the next one is b s dash, so I'll write b s dash followed by z. Then I'll take a third one, a y followed by z, so I'll just write z. Then we have b, then followed by z again, z, and then what we have this a, so I'll just write this a here. So if you can observe, here we have these production rules, and all of these production rules are now in a GNF form. This one you can see we have starting with a terminal, and all of these are starting with a terminal followed by any number of variables. So this is the final Greeback normal form of this context-free grammar. So I hope this is clear to you now. Thank you so much.